This video is going to walk you through the solution for an ALEKS problem in which you're being asked to determine the volume of base needed to titrate a given mass of an acid. So this problem tells us that we have a particular mass of chloroacetic acid. Here's its formula. And it's been put into a volumetric flask, which is information that we don't need to solve this problem. And it's going to be titrated with a 0.1 molar sodium hydroxide solution. We want to know how much sodium hydroxide solution is going to be necessary in order to complete the titration. Remember, a titration is just a fancy way of saying an acid-base reaction. This problem looks like doesn't really look like anything we've done in class, but it's just a pretty straightforward stoichiometry problem with a little bit of an acid-base neutralization reaction twist. So the first part in this problem, first part of any stoichiometry problem, is to write a balanced equation. And this one is a little bit challenging because chloroacetic acid is a tricky molecule. There's a lot of stuff going on in terms of having a lot of atoms, and it's not an acid that we see very often in class. So writing the balanced equation is really the hardest part. We do know that it's an acid-base reaction, so we want to write our acid reacting with our base, sodium hydroxide. And if you remember from when we were doing types of reactions in class, the acid in the base neutralization reaction produces water, so I went ahead and wrote that as a product of the reaction. And the water comes from the hydrogen of the acid and the OH of the base, meaning that the rest of this stuff, the CH2, ClCO2, and the Na, they come together to make an ionic compound. I'm just going to write that formula out. We traditionally write the cation first, which is why I've chose to write the sodium on the left, and then all the rest of this polyatomic ion on the right. Double check to make sure that the equation is balanced, and it is. And that, like I said, that's the hardest part of this equation. Once we have the equation, which tells us how these two things react with each other, then we can go ahead and do stoichiometry. We know from the problem that we're starting with 0.0549 grams of chloroacetic acid, and we want to figure out how much sodium hydroxide that corresponds to. In order to relate chloroacetic acid to sodium hydroxide, we need to convert into moles so that we can do a mole-to-mole relationship or a mole-to-mole conversion. So our first step is to take the mass of chloroacetic acid, use its molecular weight to figure out how many moles we have, and then use the stoichiometric coefficients 1 to 1 to figure out how many moles of sodium hydroxide are needed to react with this amount of the acetic acid. And we get 5.84 times 10 to the minus 4 moles of sodium hydroxide. The sodium hydroxide is present in a 0.1 molar solution, which means that we have 0.1 moles of sodium hydroxide in every liter. We want to know what volume of sodium hydroxide would have this many moles. So we're going to use molarity as a conversion factor to relate to or to convert from moles into liters. So we're going to take this amount of moles, the amount of moles that we need, and multiply it by the molarity as a conversion factor, 0.1 moles per liter. And that gives us 0.00584 liters, or 5.84 milliliters. And that is the solution to the problem.